Okay, explaining what I've done wrong, and you won't have to worry about this because the chart will already be started for you. And what I did wrong, and it's still, we can still see it here, I picked as one of my numbers here my vertical asymptote. You can't do that. You can't pick your vertical asymptote. So I'm going to change that number here. Instead of picking 1, I'll pick -2. Now you won't have to worry about that because like I said, in the homework in my math lab or my lab math, whatever it's called, they're going to have already picked the numbers for you. And so I should not have picked a -1 because that's my vertical asymptote, and that just isn't going to work. We've got a vertical asymptote of -1. That's just not going to work. So I'm going to pick -2, 1, and 2, plug into the original function. And trust me on this, hopefully. Oh, since I just made a mistake, maybe you shouldn't trust me. When I plug in -2 into the original function, I'm going to get 15. So all I did was plug 2 in there, plug -2 in there, and get 15. Plug in 1. And you're going to get -1.5. And plug in 2. You're going to get -0.6, roughly. I rounded that guy up. So, got a few x coordinates, find the y coordinates, then graph these things. And now I put a little axis here to start us graphing, but the idea here is we're going to take all the pieces of information we found and put it on here. So what did we find? We found that the y-intercept was -3. So 1, 2, 3. That was the y-intercept. We found that the x-intercepts were -1/2 and 3. So there's -1, 1, 2, 3. So -1/2 and 3. The x-intercepts -1/2 and 3. Plot those. We found that there's a vertical asymptote at x equal -1. So there it is. Vertical asymptote at x equal -1. So there's my vertical asymptote. And we found that there's a horizontal asymptote at y equal 2. So 1, 2. Horizontal asymptote at y equal 2. Now remember what horizontal asymptotes essentially tell you. They essentially tell you where the graph begins and ends. Then my last pieces of information, I have a point -2, 15. I'm just going to call that up there. There's -2, 15. I'm not going to count all the way up there, but I will extend my line here. And then I had the point 1, -1.5, which would be right about there. And then I had 2, -0.6, which might be right about there. And then the idea here, and back before we had calculators, you would have found many more points than just 3. But, so you'd have a few more points. The idea is that I can just kind of connect the dots, and it should work out to be roughly what I'll see when I actually graph it. And so there's what I see on the computer screen or the calculator screen. And the idea is I should be able to copy that onto what I've started here. And I can do that. Remember, horizontal asymptotes would tell me where to begin and end. So I'm going to begin there and go up like that. And then I hit my vertical asymptotes. You don't ever cross vertical asymptotes. So I'm going to jump to the other side. And then I come down through those points, hit that y-intercept, come up, and end near my asymptote. And there's my graph. And so, again, we're finding information that hopefully will help us use our calculator better, and our calculator will verify our information. And there's that graph. Then the last thing we're doing in this section, just a few more horizontal and vertical translations. So let's just call these some basic shapes here. The graph of 1 over x looks like that. The graph of 1 over x squared looks like that. And they're not particularly pretty graphs. If I try to highlight them in a little bit more. There's 1 over x. That's called the reciprocal function in some books. And 1 over x squared looks something like that. And so all we're going to do here is do some of that horizontal, shifting things left, right, up, down, sort, whatnot. And so on this guy, let me just rewrite this a little bit, put the 10 on the end. And so then we remember some stuff that we learned before. The numbers on the end, the plus 10, that's going to be a vertical translation, and it's going to go up 10 units. Then minus 6, and that's inside the denominator. But inside, the stuff that was inside the functions, that was horizontal. And horizontal went backwards to what you'd anticipate. And so since it's minus 6, that's going to go right 6. Now I'm not going to count all the way over there, but right 6, let's call that 6, and let's call that 10 because I'm running out of room. And what that's going to do, notice the axes were serving as horizontal and vertical asymptotes. And so it's like moving those axes around. And so instead of having my axes, or not my axes, my asymptotes, it's moving my asymptotes around. Instead of my asymptotes crossing at the origin, they're going to cross at 10.6. And I really did not plan my paper well here. So let's use a different color for the graph so that my blue writing and my graph don't run into each other, aren't all blue. But it moves around those asymptotes. And then you just draw that same graph in those asymptotes, and I'll do it in green. There's my graph, that you're just moving around those asymptotes. Then doing the same thing over here. The minus 8, that's on the end. And so that's going to be vertical. And it's going to go down 8. The plus 3, which is inside the denominator. And the square. Denominator and square. And we'll go down here and finish it. That's going to be horizontal. Horizontal goes opposite to what you'd expect, so left 3. So down 8, we'll just call that negative 8. Left 3, so there's negative 3. That's where my asymptotes are going. And so doop, doop, doop. Doop, doop, doop. And then I draw that same basic shape. So the basic shape's still up there, this 1 over x squared shape. Draw that same basic shape where I've just moved those asymptotes around. And so there's my graph. So it's the same idea that we did before, but you're just moving around the asymptotes. And that completes this section.